Well, good morning, everyone, and welcome to the AWS Loft, and thanks for the intro, Mark. So, my name is Clinton Ford. I'm a product manager in the EC2 team, and one of my favorite things about this role is being able to meet with you, the customers. In fact, I would say about 90% of our roadmap items come from feedback from our customers, so please take a chance while you're here in the Loft to get to know one another and also to talk about those features and needs that you have. And then share those with us. We love to hear your feedback, and this is where we innovate. The innovation begins. All right, so we're talking today about EC2. Thank you for coming to our Compute Evolved week here at the Loft. And starting off, let's just talk about a little bit about this market segment. So AWS is positioned as a leader in Gartner's Magic Quadrant. This has been the case for many years, both in terms of execution and also in terms of vision. And a lot of that comes because of our deep focus on you, the customers. And we want to make sure we continue to deliver for you in innovative new ways. And so, as you notice, too, over time with these Magic Quadrants, the number of dots on the chart actually decreases. And that's because delivering cloud computing at high scale is very difficult work. And it requires a lot of effort and coordination. And we've become even more efficient and better at doing that. And it's in order to serve you, the customer. So when we talk to customers, there's several things that we hear in terms of feedback from them. First of all, they need a broad selection of compute options to meet a wide variety of needs in their business portfolio because they have applications that are both legacy applications as well as born-in-the-cloud applications. And their needs vary quite dramatically between those different apps. In addition, there's a need for foundational security, availability, and fast performance with things like great networking and storage performance. And so we really strive to enable those things. In addition, there's a need for ease of use, to make it simple to understand and also to manage both the complexity and the cost of your different workloads on the cloud. So we strive to make that simpler and to make it easier with different cost options. And finally, we want to make sure that we have compute available for your business wherever you operate. Because as we increasingly see more and more enterprises coming to the cloud with global workloads, and their needs are very diverse across the world in different regions and different countries. And so we aim to serve those compute needs wherever those are. So let's start at the beginning with instances. So EC2 instances is where we've had a lot of experience and we've invested a lot in innovation. And one of the things that's really important to notice is just the variety of options that we give you. But let's break this down. So first of all, operating system. You have your choice of Linux or Windows operating systems. And then you have your choice of processor architecture. So x86, both AMD and Intel, and we'll talk a little bit more about the AMD announcement, as well as ARM architectures, giving you more flexibility. We have instances for general purpose workloads, as well as instances that are optimized for specific workloads, such as data analytics, in-memory databases, and other very specific use cases where we can optimize for those. We also have options in terms of bare metal, as well as disk options such as local storage or network attached storage. And we have new options for networking to really improve the performance of the networking on AWS. The images for your different instances, we call them Amazon Machine Images or AMIs, are available as packaged, prepackaged, or custom. You can build your own. And in addition, we have AMIs available from our community with a wide variety of different software packages and operating systems. And then finally, we give you many ways to purchase these instances that are flexible to meet your business spending needs. OK, so let's talk first about operating systems a little bit more. And let's start with Linux. So with Linux, we have distributions for enterprise, such as Red Hat and SUSE. We also have a lot of open source distributions, such as Ubuntu to CentOS and others. And this gives you that flexibility to be able to get the right level of support that you need, the right configuration you need. And in addition, we have Amazon Linux. So Amazon Linux 2 is the new version of our Amazon Linux distribution. And this includes long-term support, or LTS. So you have 5 years of support included with that. This is really important for enterprise businesses that need to be able to operate for a long period of time with their line of business and customer-facing applications. And these are optimized for AWS with the latest tooling and more up-to-date ways to manage your packages and installations. And you can use these both as VMs, Amazon machine images on EC2. You can also use Amazon Linux 2 for Docker containers. And it supports a lot of ISV applications. And this is available through VMs and AMIs at no additional charge, and containers at no additional cost. So this gives you a lot of flexibility. And we're seeing a lot of interest in this Amazon Linux 2. So this is a chart from IDC where they show the Windows workload usage across the public clouds. And what's really interesting is to see that 57.7% of Windows workloads on the cloud are in AWS. So we have a lot of experience running Windows workloads on AWS. We have now over 10 years of experience on EC2 running Windows workloads. And we have a lot of the tools and capabilities you need for .NET and SQL Server and the various software that you would run on Windows Server. And this makes it easier for you to bring a variety of different workloads to the cloud, Windows as well as Linux workloads, as you transition and modernize to build new applications. In addition to operating system selection, we have the broadest range of CPU architectures. So we've had a long-standing relationship with Intel in building instances together with them. And the Skylake architecture powers some of our most powerful instances today. In addition, we have announced this collaboration with AMD on their EPYC processors. And then NVIDIA offers GPUs for both graphics and machine learning applications in graphics instances as well as in our ML accelerated instances. So with AMD instances, now you have even more selection in terms of x86. And then we've also recently announced the first built for AWS Graviton processor. This is an ARM-based architecture processor. So now you can bring your scale-out ARM architecture workloads to the cloud as well. So this is very exciting. And AWS now has the broadest selection of processor architectures on the cloud. So let's take a look at the AMD option. So when we talk to customers, we realize that not every workload needs the very fastest performance in terms of processor. Some workloads are more general purpose, or maybe it's a small business bringing a workload. And it's OK to run on a slightly slower processor. And they can save then on the cost both for CPU and memory. So with the AMD EPYC processors, you can get a 10% cost savings both in compute and memory. And what's great is the seamless support for your applications and your Amazon machine images. So it's pretty easy to just launch those on an AMD processor instance. So these are ideal for general purpose and memory optimized workloads. And then as we talked about briefly before, so we announced last year the Graviton processor. This is a chip custom built for AWS and really built to take advantage of some of the capabilities that you've become very familiar with AWS and come to expect. So our AWS console, our APIs, the machine images, IAM, identity and access management, all of these things are available in a very consistent and familiar way, but for ARM-based architectures. So this is great for scale-out workloads. This is a custom 64-bit processor, ARM-based processor. And we'll talk a little bit more about some of the work that we've done to further offload for virtualization the requirements from this processor so that you can take advantage of all that capability that's in there and save up to 45% for certain workloads that support that scale out. So again, with the A1 processor, some of the key benefits are a wide variety of architectures that you can choose from, a lower price point, and the ability to bring some of these ARM-based workloads to the cloud that in the past haven't been able to run. And a lot of this innovation is powered by our Nitro system. So when we looked at virtualization several years ago, we realized that we could do more to offload some of the networking, storage, and compute work that we had to do in the virtualization in the hypervisor into hardware offloads. And so we built custom hardware offloads to help take some of that workload off of the CPU and give more of the CPU and memory back to you as the end user. So now we can virtualize the CPU, the memory, and the storage and networking at a much lower impact on those physical resources. And this has enabled as well better security. We have a security chip on there that can check the BIOS, make sure all of the hardware configuration is as it is expected as it starts up, and to make sure that you have the stability and security that you need while enabling even faster performance. And in addition, there's management software that needs to run to manage these different, within the hypervisor, to manage the different virtualized instances. We've offloaded a lot of that. And so this Nitro system is what's enabling us to do even more innovation at a faster pace for you on the cloud. And so if you have other requests, feel free to let us know, because now with Nitro, we can enable some really amazing scenarios. We'll talk about some of those today. So as we've discussed, with AWS and with EC2, you get a really broad range of choice for general purpose workloads, for burstable workloads, and now optimized instances for things like in-memory databases, for analytics, machine learning. And we've added new capabilities. So the choice of processor, we have an even broader range of options there. Now with faster networking up to 100 gigabits per second. And now we've also got the ability for you to take elastic graphics and bring some graphics power and elastic inference to bring some inference capability to your instances as well. So now we have 175 different instances. And in the past year, we've launched 3 times as many new instances as in the prior year. So we're constantly coming up with new innovation in this space to make sure we have the perfect match of our instance type with your computing need. So as an example for these optimized use cases, we introduced high memory instances. These are great for SAP workloads and enable you to store a lot of memory, a lot of the database in memory with 6, 9, and 12 terabyte instances. And we have the new 18 and 24 terabyte instances coming this year. These are based on the Xeon processor, also built on the Nitro platform. And then we announced Z1D, which is optimized for both memory and CPU-intensive operations, such as electronic design automation, or EDA. And this enables customers to take advantage of a new all-core sustained 4 gigahertz processor, the fastest processor on the cloud, to do high-performance computing workloads. And we're even seeing it accelerate database workloads that are CPU-bound. So if you have queries that are CPU-intensive, we're actually seeing a license cost reduction using Z1D, because you're able to consolidate onto fewer cores and vCPUs. So a couple of examples on the high memory instance side. Whirlpool has been an early adopter of HANA and moving to SAP HANA and bringing those into colos and other locations in the past couple of years. But they really wanted to move it to the cloud because it's more consistent, it's better optimized, and it just reduces the management overhead. So they've been migrating some of their workloads now to the cloud and are seeing excellent performance. One of the things that we've seen is much faster load time. So where it maybe took 8 hours to build one of these systems, they can do it in about 45 minutes with the faster processor performance and the Nitro system and faster networking. So it's really enabling faster migration of these critical business workloads. Another example is Synopsys, who is working in the high-performance computing space. They've been using the Z1D instance. So they've seen much faster performance with the sustained all-core 4 gigahertz CPUs on the Z1D. And they're using this for semiconductor design. So it's really reducing the footprint that they need to do these simulations and accelerating the pace of their innovation for their customers. And so we're excited to see customers like ARM, like Synopsys, designing next generation chips on the cloud where they can take advantage for their product development cycles of this additional capacity that we can enable. So as we talk about these scenarios, I hope you're thinking about your workloads, about your applications, both the things you currently have, but the things that you want to build for innovation. And then talk with us, and let's see if we can leverage existing instances or if we need to build new capabilities to enable those. Because that's really where the excitement happens, is when we're creating this innovation together. So one of the things we mentioned briefly was faster networking. So enhanced networking has enabled some of our previous instances to bring more of these high-performance computing workloads over. And we recently announced C5N, which is now the most elastic and scalable networking that we have on the cloud, with up to 100 gigabits per second. And we're seeing with this Xeon scalable processor much faster performance for these HPC workloads where there's a lot of internode communication that used to be a bottleneck. Now they're able to go even faster and deliver much larger HPC clusters on the cloud. The other instance that we've recently announced that's an optimized one is the P3DN. So P3 is our machine learning instances with the NVIDIA GPUs. And the DN now has local disk as well as faster networking for even faster machine learning on the cloud, because you need to load those data sets in, you need to be able to bring in and process that information. So the key is being able to saturate those GPUs with all of the information that they need to really take advantage of all that GPU compute. And this is all enabled with Elastic Fabric Adapter, or EFA, for HPC. And so now we're seeing customers using P3 and P3DN and C5N for HPC workloads on the cloud. So the P3DN includes 96 Skylake CPUs, 768 gigs of memory. The GPUs each include 32 gigs, and now there are 8 of these NVIDIA GPUs on them. So very, very powerful instances. And you may wonder, well, why would I need something so powerful and fast? Well, with machine learning, a lot of it is about the time that your data scientists are spending waiting for a job to complete. So why have them sitting around waiting for this or running something overnight when they can just get it done while they're in the office? So, and we'll talk about this a little bit more in our next session about accelerated compute on AWS. So now we have a choice of accelerators for your workloads as well. So this gives you even more flexibility with elastic graphics. If, let's say, you're doing a high compute-intensive operation, but then you need to be able to visualize something, so you need a little bit of GPU to render for graphical output, you can do that. You can attach elastic graphics to those instances. The other thing we've announced recently is elastic inference. So if you have a machine learning model and now you're going to deploy that into production, and you need to be able to run a lot of inference now on that model, you can actually attach elastic inference and be able to save, cut your cost by up to 75% by just bringing that inference capability to that instance, right where your data are, rather than having to spin up a separate instance. And so this is the kind of innovation that we're able to enable on the cloud. And it's because of the feedback from customers like you that we've pushed the boundaries in this direction. Because like I said, about 90% of our roadmap comes from customer feedback. So please, if you have ideas or thoughts about what you want to build on the cloud, let us know. Talk to us at the Ask an Expert bar here, and talk with our solutions architects. See how you can take advantage of this, because now it supports auto scaling, so you can actually scale up that inference. So if you get unexpected demand for your mobile app, let's say, that's doing a bunch of inference on the fly, you can handle that capacity with auto scaling. Okay, so now every great compute cloud provider needs to also have a great network behind it. So in order to support these compute workloads, you also need amazing and powerful networking. So we have a world-class networking capability to support that. So let's talk a little bit about our network. So our networks consist of 6,900 fiber count cable, which is the highest in the world. And if we look at one region, like our US East 1, North Virginia region, we have over 2.6 million miles of cable. And if you take all those strands and lay them end to end, you can actually go to the moon and back twice. And that's just one region. So to give you an idea, like we are making big investments in networking because we know that having that availability around the world and between your availability zones is critical to making sure you deliver the performance you need to for your customers. If you can, just hold your questions to the end. We'll have time for Q&A at the end. But yeah, please get back to me at the end with your question. So as we talk about network performance, we have a long history of making some improvements to our networking. And you'll see that we've recently announced with C5 the elastic network adapter, 25 gigabits per second networking, and now twice as many packets per second, and even lower latency. So this is really helping for especially like high performance computing use cases. And now with C5N, we have the elastic fabric adapter and 100 gigabits per second. So twice as many, over twice as many packets per second. So we're really improving the throughput of our network. And what's great is even over time, we're going to continue to optimize and improve it. So what you see today in terms of networking performance, you can expect that to just continue to improve. OK, so in addition to networking, we also need great storage to be able to give those compute workloads all of the data that they need. And this is an area where we've been a leader both in execution and in our vision in the Gartner Magic Quadrant. And we'll talk about some of the innovation here and why this is the case. But really, it comes down to your needs, basically being able to meet the wide variety of storage needs that you have for your applications. So we have some ultra low latency instance storage. This is one of the things you'll notice is we have these instances that end with a D, the small d. That means local disk or local storage, or instance storage as we call it. This gives you the lowest latency, highest throughput storage. And because some applications, they don't need to go out to a shared file system or shared storage. They're not storing vast amounts of data. They just need to be able to get to some local data very quickly. And so this enables very fast access so you can keep those GPUs or the CPUs saturated with work and information. So very optimized for high random IOs. And so this is great for in-memory databases and being able to have caches for high performance computing and the like. And as you can see, it's available for i3, C5D, the M5D, R5D, Z1D, and F1. So we're making this available to more and more instances. And we're seeing it's quite a popular option. So the difference with the instance storage is it's not as durable. I mean, it's designed to be a very fast access and designed to be a place where the applications can store a vast amount of data and be able to access that quickly. If you need higher resiliency and redundancy for your data, we have options that from EBS, which is our elastic block storage. So this is network attached storage. And we have several different flavors of that. We'll go into that in a minute. And then we have elastic file system, which is file-based storage. And then S3 for object-based storage. And we've got some new innovations we've recently announced for S3 to help lower the cost of storage, to help you automatically move from frequent access to infrequent access, and also with Deep Archive to be able to store it in Glacier at a much lower cost for data that you may not need access to in the near future. And then let's look at EBS in a little bit more depth. So on the EBS side, we have both a solid state and hard disk based EBS. The IO optimized or provisioned IOPS SSD IO1 now has a 2x improvement. So it was 32,000 IOPS, now 64,000 IOPS. So you can get the highest throughput. And then GP2, which is our general purpose SSD, is our most popular option. We've also made some big improvements there for performance, a 60% performance improvement for GP2. And then for streaming data, if you need low cost, large volumes, we have our spinning disks. And there we have the throughput optimized and the cost optimized hard disk drives. And so as we talked about some of the options that you have now in terms of the instances and the storage and networking, now let's talk about managing for cost and complexity, because as you bring more and more workloads to the cloud, you need to make sure it's easy to manage and to make sure you're not overspending. And so we're going to talk about some ways that you can do that on EC2. So in this graph, one of the things that we typically encourage customers to do is if you can identify that blue section, your baseline of what you need running all the time, for that you can purchase what we call reserved instances. This is capacity you reserve in advance, and for that reservation we give you a significant discount. Then you can purchase additional capacity on demand, which we call OD or on demand. It's a higher cost, but gives you that flexibility to grow and shrink your capacity. And then in addition to that, we have Spot. Now, Spot is basically purchasing unused capacity on EC2 for 90% discount. So it's like booking a flight at the very last moment and grabbing that available seat. You can get amazing discounts if you can leverage Spot. Now, what's great is we have some new services that take advantage of these different pricing models, such as auto-scaling that can automatically scale up and take advantage of these different instance purchase models, and things like EC2 Fleet that can be integrated with auto-scaling, so you can actually have a strategy for how you want to optimize your spend. So for example, you can say, I want to be able to use Spot if possible. If it's not available, go for on-demand. And that way you can meet your baseline capacity, but also grow as the need comes and still minimize your cost. So with EC2 instances, one of the things we recently announced is the ability to hibernate. So this makes it even simpler to stop your instance and pick up where you left off. It's kind of like closing your laptop and just putting it in Hibernate. So basically all of the application memory is kept around so that you don't have to reinitiate all of that. And that saves you a lot of time when you need to pause a workload. And that enables you to be able to pause those and not lose that memory so that you can save even more costs when you're not at, if you have a virtualized workstation or something, you can just essentially pause that and not have to reload all that memory when you go to resume. So now you can hibernate. This is enabled to pre-warm your instances as well so that you get faster launch times when you need to grow your capacity. It uses the same stop and start APIs, so it's integrated with the existing API. And all the contents of memory are encrypted, so you don't have to worry from a security perspective. That is stored in a secure way. Now, in terms of scaling, as you think about your on-premises workloads, typically, you would have to buy hardware in advance of a major cycle in product development or a customer, demand or usage, and that could be very spiky. And of course, you might over-provision. You would have to buy more hardware than you're going to need in order to make sure you deliver a great experience. Well, we introduced the ability to do target tracking. But the challenge here was that, as you can see, your capacity would ramp up slightly behind demand. And then going back down, as the demand scaled down, it was slightly behind coming down as well. So you're spending a little bit more than you should on the way down, and you're not expanding your capacity quite quickly enough on the way up. So now we've introduced this new capability called predictive scaling that takes the information we know from EC2 across millions of different deployments to look at likely needs in terms of increases in capacity to predict that for you and help ensure that you have the right amount of capacity at the right moment while minimizing your spend. So this is a great new feature that helps and integrates with auto-scaling so that you can scale up as you need with the right amount of capacity. Now, for high-performance computing workloads, there was a lot involved in that. So you've got typically up to thousands of nodes connected, and they need some sort of shared file system for storage and for the data that they're going to process. Then there's also a master node or instance that is, creating and instantiating these nodes that are taking care of the jobs. And then you've got some software that does the queuing and the management of the actual jobs that go into these HPC clusters. So we've announced a new capability to simplify all of this on AWS, and it's built on the open source CFN cluster. So all that work that customers had to manually do, now a lot of that is offloaded with this AWS parallel cluster. So AWS parallel cluster provisions your shared file storage. It manages the instances, and it integrates with many different cluster softwares such as AWS Batch, SGE, Slurm, and others, so that you have a choice in terms of what kind of software you're using, and then a lot of that management is handled for you. So AQR Capital is a great example. They're able to see most of their jobs start up within 10 minutes. So it's a big reduction in their queue because these HPC clusters often get far more jobs than they can process. But with the cloud, now you can process them on demand. And HPC today probably represents between 2 to 5% of the overall cloud computing segment. But obviously, it's going to grow now that it's so much easier to bring these workloads over to AWS and run them on the cloud. So a good example of this is a company we acquired called ThinkBox. So AWS ThinkBox is run by studios like Milk, a very small studio, but they were able to do this simulation for this movie Adrift of the waves and the motion, the rainstorms, and it looked very realistic. And they won some awards for this. And they were able to compete with much larger studios because they were able to take advantage of ThinkBox. And ThinkBox helps manage all of that compute capacity on the cloud. And so for various industry verticals, whether it's in computational fluid dynamics or in media and entertainment, in genomics, we're able to now handle a lot more of these workloads on the cloud, and very interesting breakthroughs are happening there. So if you have a need in HPC, let us know. We'd love to talk with you about that and see how we can leverage some of these technologies to help out. Now, the other end of the spectrum, we've been talking about HPC. You've got customers who just want to launch a simple SharePoint portal or a WordPress site, and all of this work about setting up IAM roles and a VPC and understanding the different EC2 instance types may be too complex for them. And so what we've done is we've created a service called Lightsail that bundles your networking, storage, and compute all together and gives you just what you need with the packages that you want. And we've introduced recently the ability to have managed databases. So you can power those workloads, those applications, with databases that are fully managed. And if you find that your workload is growing significantly, there's an upgrade path to EC2, so you can take advantage of the full capabilities of EC2 when you're ready. But this is a great way to get started. If you're thinking about beginning on EC2, take a look at Lightsail as a great way to get going. So it's an amazing way to handle both things like a MySQL database, Windows-based workloads, as well as Linux and open source workloads, without having to understand the full capabilities of EC2. So we've talked now about being able to have this wide selection, having the management tools, being able to have the latest networking and the storage capabilities. Now let's talk about compute everywhere, because not all of your business computing needs are in one location. They may be in many different geographic locations. And some of the feedback we've heard from customers is they need, for many different reasons, to have many geographic locations. So we have a wide variety of regions, 19 regions, with 55 availability zones, or AZs, as we call them, for redundancy. And then we have over 150 points of presence with our cloud delivery network with the content, the CDN CloudFront, as well as 89 direct connect locations. So you can be very close to your data center for low latency. So this has really helped customers who have various regulatory needs to keep data in a certain region, or they need to be able to replicate data and have it as close as possible to their customers. And what's really driving the demand for hybrid is the low latency. Having the compute resources really close to your data center, if that's where this is located. And customers have been asking us to have the same software, the same console and interface, the same APIs, but be able to move it even closer to their data centers, to their on-premises sites. They need the same development tools. They don't want to have a separate set of management tools. They want to be able to manage this in a consistent way. And they want to have this work both in the cloud as well as on premises. And this can be a great way for customers who are looking to migrate to the cloud, but for, again, certain regulatory reasons or for latency issues are unable to move those to the cloud. So after looking at this feedback and considering different ways we can meet this, we announced AWS Outposts. So think of AWS Outposts as a private subnet where you can launch your AWS instances. You can move your data there. You can provision a volume. But it's run on an instance, a single unit, or a whole rack, or many racks of capacity that you purchase, and that either you install yourself or have AWS help you with that installation. We still manage all the software patching and updates for you. And if one of the hardware units fails, you just pull it out of the rack, and we send you another one, and you slot that in. You're back up and running. And this is available in 2 flavors. So a lot of our customers run VMware, and they have virtualized environments, and they would like to be able to use vSphere as their interface for that. So VMware Cloud on AWS will have an option for this in this modality to be able to run on premises, as well as an AWS native. So whichever works best for you. In either case, we handle the updating and the management of those instances so that you don't have to worry about that. And it just really reduces the overhead, and it's a great way to begin that migration to the cloud and also meet the latency requirements for very sensitive, performance-sensitive applications. So we're excited about this. This is coming in the second half of this year, and we'll have more details available as that gets closer. But we're very excited about this, and it really comes from feedback from you, the customer. This is something you've told us that you need, and so we're responding and excited to roll this out. So let's talk a little bit about how this works. So again, you can deploy multiple racks or just a single unit in your data center. And you can order these for multiple instances or half racks and full racks, and they integrate seamlessly into your data center. So you can configure it, connect it, launch it, and build it. And you can use the same development tools. You can use the same management tools. So you would go into the console, for example, and just as you would today launch an instance in a particular VPC and subnet, you would just choose your AWS Outposts as a place to launch that. Similarly, setting up a volume, if you want to have a storage volume there, you can set up your storage to be there. So now your compute, your memory, and your storage are all there under your roof and provided through the same APIs and interfaces that you become familiar with. And then you can choose to have AWS support you and help you with that installation, or you can manage it yourself. And then you can replace hardware as needed by just pulling that out of the rack and inserting a new one will ship to you. So again, that's coming second half of 2019, and this helps fulfill the vision that we have of having compute everywhere that you need. So whether it's green grass for edge processing, or snowball edge, where you need some storage and compute at the edge for disconnected scenarios, say in a ruggedized environment where you may be away from shore or disconnected from the network, to AWS Outposts, where you need to have a very low latency connection to your data center, and then all the way to cloud services in the cloud, where we provide the compute and all of the storage and memory and resources networking in the cloud on your behalf. All of these are different options for you, and that's the great thing with the cloud, is that we're bringing these new ways for you to connect and to support all of your different applications. So now you get to bring your creativity and think about how you're going to use this, take advantage of these things. And it's great to see startups as well as enterprises building brand new things that no one had ever imagined before that are all enabled by the cloud. So just to recap, we've talked about the broadest range of platform options, operating systems, CPU architectures, fast networking and storage, the ease of use that you expect, being able to manage your costs and have abstractions for being able to scale up and down. A great example of this is Western Digital. So they do head design for their hard disk drives, and they had to run millions of simulations, and typically it would take them about 20 days to run the simulation. Well, they were able to use spot capacity. They didn't even need to come to us. They just did this on their own. They just leveraged some spot capacity and were able to launch 1 million vCPUs and complete all those simulations in 8 hours. So it dramatically cut their costs and time for these production cycles and testing cycles. And that's what we're hoping to enable for you as well, is to be able to leverage, and focus on what you do best, and let us help on the compute side to deliver the compute capacity you need when and where you need it. So this is just kind of a recap of some of our recent announcements, just to give you an idea of all the things that are happening. We didn't have time in this session to go into all of those, but just wanted to help you be aware of some of the new things that are always happening on the compute side. And whether you're new to EC2 or you've been using it for a long time, we are trying to make it the best place for all of your compute needs. Okay, so what to do next from here? So first of all, learn about some of these announcements, take a look at some of our reInvent sessions, and hear from our customers who are taking advantage of these things. And then begin thinking about what workloads you would like to move to the cloud, or new things that you would like to build on the cloud, whether Windows-based or Linux, and leverage third-party licenses on the cloud. We have a new service called AWS License Manager to help you manage your licenses on-prem and on the cloud. And then innovate with us to help shape the roadmap for ARM. Because as more and more ISV software is enabled for ARM architecture, we want you to be able to tap into that and further reduce your costs. We've seen cost savings of about 45%. We'd love to help you save massively using this new ARM architecture. Then bring your HPC and machine learning workloads to the cloud. Let's see if we can accelerate those. Let's build some new innovation. Let's accelerate inference. And then let's spin up Spot instances. It's a great way to play around with the cloud, too. You can just go in and use Spot as a way to start up these big instances and play around with them at like up to 90% off the typical price for those. And then sign up to get more information about AWS Outposts. This is something brand new. It's still in development, and we look forward to meeting your needs in that regard. So these are some areas where we can collaborate together, and we'd love to hear your needs. So now I think we've got a few minutes left for questions. I think we want to take maybe 5 or 10 minutes to take some questions. So we had a couple questions in the room. So first of all, go ahead and okay, so the question is, when you're moving data between regions, across regions, is that through Direct Connect, or is that through the public internet, or how is that done? Okay, so if you're making an API call from one region to another region, and what is the question related to that? How is that connected? How is that network connected? So AWS provides networking between the regions so that you can stay on the AWS network between those regions. So for API calls, you can make those API calls across regions. Now, if you're transmitting data, if you're moving data between regions, there could be some cost involved for egress of data. But yeah, those API calls can happen on the AWS network. And we have a new service called AWS Private Link. Private Link enables you to front your ELB or ALB with a private endpoint. So I'd say about half of the S3 usage today is using private endpoints. And what that means is calls to S3 don't go over the open internet. They stay within the Amazon network, essentially. And so you can do that for your own SaaS as well. Or if you have a microservice, you can actually put a front-end ELB or ALB in front of that and use private links so that any calls from your customers or from your own departments and internal divisions all happen in a very secure way.
So I was asking from one AWS region and the cost to another AWS region.
Oh, the cost?
No.
I'm sorry, the call. Oh, the API call.
In another region. So it is
Okay.
through AWS network, or is that public network?
Through the AWS network, we provide connections there. So it just needs to be configured in the right way. And that's where you want to talk with your solutions architect to make sure that you're making those calls through the AWS network. So yeah, there are various ways to do it. And so I'd love to chat with you afterwards about your specific use case and which APIs. Great, yes.
Couple questions. The first one on Lightsail.
Mm-hmm.
Is it only Windows instances,
Linux and Windows, yes. So you can choose your operating system as well as the software package. There's prepackaged options for things like WordPress or Exchange or SharePoint. You can choose what you'd like to have configured. Okay, so the question is about the pros and cons of burstable instances and hibernation. So, so obviously with the burstable instances, with higher performance or optimized instances, there's additional cost. So you want to look at that over time to see, is it better to burst to handle the additional volume, or to use Spot? I mean, that can be another way, is to scale out using Spot. So those are some ideas to take a look at. And then regarding hibernation, so hibernation is a great way to keep your instances warm. If you know you're going to have a lot of demand, you can essentially pause those. Or if they're used by individuals like virtual workstations and things like that, that you can keep all of the information in memory and ready to go. So it's a great way to just pause what you're working on and not have to pay for the compute capacity. Okay. So the question is, if there's a workload that just runs at midnight, for example, each day, yeah, so there's a number of ways to kick that off. You can use scheduled tasks. You can hibernate the instance and have that automatically start up. So there's a number of different ways you can use that, using Lambda functions, and using a cron job and other ways to do it. But yeah, you definitely want to turn it off during that time that it's not really being used, because you'll see massive cost savings for sure. Great. So the question is there a cost for hibernation of the instance? So there's a charge for the EBS storage, because we encrypt the memory and store it on an EBS volume. So you're going to be paying for the EBS storage, but it's a much smaller cost than paying for the entire instance and all the memory and CPU. That's what? The question is that EC2? Oh, for EMR? You're wondering if you can use hibernation with EMR? I'd have to follow up with you on that. Let me double check. Yes, EC2 can. Mm-hmm. Any other, sorry, what can do that? Oh, any other services that you can hibernate? Let's double check afterwards to see, because it may be supported. Services that use EC2 may be taking advantage of Hibernate already, but let's take a look right after this to see if that's the case. Yes? Mm-hmm. Okay, the question is so we know that you can migrate from Lightsail to EC2. Can you go the other direction from EC2 to Lightsail? That's a great question. So let's follow up afterwards, because I'm not sure about that. I haven't seen a request for that much in the past, but it's a great question, because what if there are customers who feel like these workloads are very small, let's just move them to Lightsail? What's the best path to get there? So let's follow up afterwards. I'll help you get that answer. Yes, over here. Okay, there was a question about security built into the chip and what cybersecurity tools that we have. So we have a lot of certifications in terms of security that we've worked with independent agencies to validate, such as ISO and NIST, and HIPAA, the Healthcare Act in the U.S. And so we use encryption both on the device, and then we have customers using in-transit encryption as well. And we have services like KMS, the key management service, so you can either use auto-generated and auto-rotated keys, or you can bring your own keys as well. and manage those keys so that it's encrypted and only you can use those keys to decrypt it. And then, of course, we take advantage of the latest security technologies from Intel, as well as in our hypervisors we talked about with Nitro. We're checking the BIOS. We have checks to make sure the BIOS and the system state is as expected, that nothing's been tampered with. And so that's another security check. And it's great because that Nitro card is actually made by AWS. So again, it further reduces the risk in terms of cybersecurity. But yeah, we're actually running a lot of amazing workloads like APHL AIMS, which is the platform that the CDC uses. So we have clinical labs in all 50 states who use that for reporting disease and health information, and also for running their compute and analytics workloads in the cloud. And it's great to see large enterprise firms like Capital One who are moving all their data centers to the cloud and able to take advantage of security in the cloud that we provide, and as well as building their own centers of excellence internally to have great security practices. So we've got customers who've achieved high trust, NIST and high-tech and other standards on the cloud. And they're doing that because they start with that foundation that we provide, and then there's a shared responsibility model that they're responsible for the application and OS stack up. And then, of course, the other big thing is patching. So I think that's one of the other advantages we're seeing on AWS is having the prepackaged AMIs with the latest patches and updates, software updates for you. And so that really helps to mitigate a lot of the risk. So it's a two-way journey. You have your portion of the shared responsibility model, and we're doing our half. And together, we're able to bring some very significant regulated workloads to the cloud.